a bubble has surface tension S. The ideal gas inside the bubble has ratio of specific heats this. Okay. The bubble is exposed to the atmosphere and it always retains a spherical shape. The atmospheric pressure is PA1, the radius of the bubble is found to be R1, and the temperature of the enclosed gas is T1. When the atmospheric pressure is PA2, radius of the bubble and temperature of the gas are R2 and this respectively. Okay, so option A, if the surface of the bubble is a perfect heat insulator, that means that the gas inside the bubble, it can only undergo like adiabatic processes, right? So we have, see, if the outside pressure is PA1, then the inside pressure is going to be PA1 plus 4T, T means S, 4S by R1, let's say the radius is R1. So PA1 plus 4S by R1, and then if it's PA2, then we have PA2 plus 4S by R2. And now, since they told it's like, what do you call, adiabatic, so now we have it's a soap bubble, right? So it's 4S instead of 2S. I hope you understand that. It's a soap bubble. I'm assuming, like, to be fair, if it's a gas inside a bubble, that means the surface of the bubble is liquid. It has to be a soap bubble. It can't just be like a water bubble or something, right? So yeah, we have PA1 plus 4S by R1. This P into volume is equal to 4 by 3 pi R1 cube. PV power gamma is equal to PV power gamma. So we have R2 by R1 whole power 5 is equal to PA1 plus 4S by R1 by PA2 plus 4S by R2. So A is wrong. Wait, is A wrong? Yeah, A is wrong. If this, but then in that case, okay, so let's say A is wrong. A is wrong. Now what about B? If the surface of the bubble is a perfect heat insulator, then the total internal energy of the bubble, including its surface energy, does not change with the external atmospheric pressure. Including the surface energy. Now that's questionable, right? What about? Well, the surface energy does change, of course. That is the surface energy changes. But as like if okay, think about it like this. No, I don't know this, okay? I don't know if this is correct or no. But then we know for the fact that there's no like Q coming in from the outside to the inside, right? And just like as a thought experiment, if the bubble expands, surface energy increases because surface area is increasing, but then the volume of the gas increases, which means temperature decreases, so internal energy decreases. So I'm assuming that would mean that the total energy is same, somewhat. I'm not sure about this, but then like as a rough guess, I would mark B to be correct. But then honestly, that's a bit risky. Depends on what you want to do in the exam. It's a bit risky to mark B, but then by some logic, I just mark B. Let's see. Let's just go with it. Now, C option is if the surface of the bubble is a perfect heat conductor and the temperature and the change in atmospheric temperature is negligible. So this is just this equation, but then without the gamma, right? So P1 V1 is equal to P2 V2. Now over here, instead of 5 by 3, we just have 1. So we have R2 by R1 whole cube is equal to, so like this 5 by 3 is not there. So it's just going to be cube is equal to this exact quantity. So C is correct. It's just the reciprocal. C is correct. And then for D option, they're asking the temperature relation. So we have T1 V1 power gamma minus 1. So we have T1 into volume 1 is 4 by 3 pi. Oh wait, sorry, they're asking in terms of pressure, no? So we should go like this. PV power gamma is equal to constant. Volume is equal to temperature by pressure. So we have T power gamma, P power 1 minus gamma. So we have T power 5 by 3, P power 1 minus 5 by 3, which is minus 2 by 3. So we have T power 5 by P square is constant. Right. So we have T2 power 5 by PA2 plus 4s by R2 whole square is equal to T1 power 5 by PA1 plus 4s by R1 whole square. So we have T2 by T1 whole power 5 by 2 is equal to PA2 plus 4s by R2 by, you get the point. So D is correct. So I'm assuming the answer is BCD. Let me just check the keys. This is question number 11. The answer is... Oh, wait. Oh, the answer is CD. So B is wrong. Honestly, again, I took a risk and then it did not pay off. So I guess that's just more like, don't gamble, you know what I mean? Just don't gamble in exams. So, yeah.